Alright. So Alia, can you share the screen to us, to the rest of the class, to show the physics spoon application? Yeah. Alright. So everyone, please use the physics spoon inside your iPad. Okay. Have you opened it? Everyone, have you opened it? Thank you, Alia. Okay, so please, those who are still not find where to open it, okay, please check into the menu, then you will find the gases. So please click that gases. There is a air box there. So anyone with problem to open the physics spoon? Yoo-hoo! Alisha, say something. Is it okay?
Mine is okay, teacher.
Yeah. What about Nuha Afika? Can she open it? Physics spoon? Nuha Afika?
Yes, teacher.
Okay, baik. So everybody, please open the physics spoon and check the gases box, air box. Okay, so what you see there? What is inside the air box? Can you see that it is very clear? Inshira, what did you see inside the air box?
Atoms, teacher?
Atoms, okay. Zulaika, what do you think?
A molecule, like moving.
Yes. So actually, gas is made of tiny particles, a zillion of tiny particles, and it's moving randomly. Okay. So for today's lesson, we want to learn to investigate what actually happens inside the gas. Okay, we want to learn more about the gas. What will happen to the gas when it is being heated? What will happen to the gas when it is being cooled under lower temperature? Okay, now girls, can you see the button lock P, lock V, lock T? Okay, I want you to press the lock P. Press the lock P. So P there is for pressure, V is for volume of the gas, and the T is for the temperature of the gas. So we want to play a bit around the button here. Okay, so actually, if you touch the box, you can move the box here and there. It is a 3D. There Alia has just moved the box. Okay, so we want to look what happened to the volume and the temperature. Okay, so you can play around with this button. Okay, first of all, I want you to know about there are three variables where we describe about the behavior of the gas. Okay, the three variables is first just now I said, what is it?
Pressure.
Pressure, yes. The second one is the volume of the gas, and the third one is the temperature. Okay, so now we want to discuss about the pressure. So how do the pressure of the air molecules ataupun gas molecules occurs in the air, in the gas? Okay, can you see, Nuha Afika, can you describe about the motion of the gas, the particles of gas? Nuha Afika.
The gas particles move vigorously.
Yes, they're moving here and there. And can you see that some of them hits the wall of the box? Yeah, okay. So the pressure of the gas is come from when the particles of the gas hit the wall of the container, wall of the box. The faster they hit the wall of the container, the higher the pressure. You get it, Iman Nadira? Can you repeat what I said just now? Where do
I get it.
yeah, where do the pressure of the gas come from?
The collision between the particle and the wall.
Okay, so what happened? What do you say when the pressure is high?
When the pressure is
Ah.
high,
What happened to the molecule? What happened to the yes?
heat and
Pardon?
The molecule move faster because of heat energy.
Okay, thank you for your opinion. What about Afrina? Just now I've thought something else about the pressure.
From what you said just now, you said that when the faster the particle hits the wall of a substance, the higher the pressure of the
Yes,
air.
thank you very much. That's the answer. Okay, so the pressure of the gas come from the particles hit the wall of the container. When the faster the particles hits the wall of the container, it's become high pressure. Okay, do you understand? All right, now we move to volume. Okay, volume. All right, Alia, can you press the plus button for the volume? Okay, everyone, can you press the plus button? Volume, the volume button at the below. See. Yes. Alia, hold on. Okay, now the volume of the box is smaller. Okay, I want you to observe the distance between the particles. Okay, make it bigger volume. Alia. So the rest of you also can play around with the volume button. Make it bigger, Alia. Make it bigger. Make it bigger. Yeah. Okay. Now I want you to observe the space between the particles. Bigger, bigger. The maximum one. Okay, everyone. Can't you see that? Yes. Yes. Very good. Much bigger. Much bigger. Okay. Can't you see that the distance between the molecules is getting further and further when the volume increase? Can you see it? Okay, Alia?
Yes.
Yes. So the volume, okay, we can say that the volume of the gas actually is the distance between the particles. So the further the particles distance with each other, the larger the volume of the gas. Okay? Inshira, do you get it? Can you repeat it?
The further the particles are, the larger the volume of
The further the particles are, the further with what?
the larger the volume
The
is.
further the particles between each other. Okay, the greater the volume. Okay, now look at the temperature. So what happened when we increase the temperature? I want you to observe the speed of the molecules vibrate. Okay, Alia. Lower the temperature. Okay, look at the motion. Lower the temperature, not the volume, dear. The temperature button. Temperature button, yes. Okay, so when you decrease the temperature of the button, the temperature of the gas, the volume seems like respond to the temperature changes. Is it? Uh, it becomes smaller too. All right. So the temperature actually shows the energy, the kinetic energy of the gas. Right. So when we heat the gas, the energy from heat, okay, give the kinetic energy to the particles. So the particle will move faster, will vibrate faster and faster and faster. So when we increase, when the temperature increase, the energy also increase, and the space of the molecule getting further and further. Right? So please remember that the temperature shows the energy, the kinetic energy of the particles. Okay, understand? Okay, just now I said that temperature shows the kinetic energy in the particle. The higher the temperature, the higher the kinetic energy. Alright? The second one is about the pressure of the gas. The pressure of the gas, the higher the speed of the particles hits the wall, the higher the pressure. Okay? And the last one, it's about the volume. The volume can be described by the space or the distance between the molecule, between the other molecules. So the further the distance, the greater the volume. Okay, everyone? Is it clear? Okay.
Yes,
Yes,
teacher.
teacher.
Okay. Yes. Okay. I give you 3 minutes to play around with the button. So you can see what happened when you increase the temperature and what happened to the volume. Okay, 3 minutes. Come on. Look around with the application. Is there any question you want to ask? Everyone okay? Yeah. If you press the lock V or lock T, there will be another story. Okay. But today we want to discuss when we lock the pressure. Okay. All right. Thank you, Alia. You may stop the presenting. Okay. Right. So far so good, everyone. The main point is about the pressure, the volume, and the temperature. Yeah. Okay. Where is my keynotes here? All right. All right. So now, okay, this is a particular. I just copy the picture. Okay, I want to ask Alisha. Just now we discussed about the pressure of the gas. Can't you explain it? So I wrote it here.
The pressure will increase when the collision between the particles and the walls is faster.
Okay, so the greater the speed of the particle hits the wall, the greater the pressure. Is it?
Yes.
Okay, so can you repeat it again?
The greater the pressure, the faster the collision between particles and the walls.
It should be the other round. It must come from the speed of the particles hits the wall first. Then it will respond to the pressure. Okay, so the higher the speed of a molecule hit the wall. Yes. Okay, the higher the
The
pressure.
pressure.
Okay, very good. Thank you very much. Okay, the next one, temperature. Uh, Nisa?
Yes, teacher.
Yeah, can you describe about the temperature?
The higher the temperature, the higher the kinetic energy.
Yeah, the higher the temperature, the higher the kinetic energy. Okay, very good. Okay, the next one. What about the volume? Afrina.
Okay, so the further the distance between molecules, the larger the volume.
Yes, the further the distance. Yeah, again, come again. The further the distance
Between molecules,
between the molecule,
the larger the volume.
the larger the volume. Yes. Okay, everybody? Do you understand? Okay, so this is the main variables that you must know about the gas. Okay, now, next. Okay, just now we discussed about the pressure, the volume, the temperature. Now, I would like to introduce you to the gas law. Just now we discussed about the behavior of the molecules of gas. Okay, so there is 3 variables here to describe about the gas law. But for the gas law, it's involved only 2 variables. Okay, so the other one variable must be constant. Okay, do you understand? There are 3 variables, but we want to find or investigate the relationship between the 2 variables only. So the other one must be constant. Okay, for example, if you want to find the relationship between the volume and the temperature, so the pressure of the gas must be constant. Okay? If you want to find the relationship between the volume and the pressure, so what must be constant?
The temperature.
Yes, the temperature must be constant. So if you want to find the pressure and the temperature relationship, so the other one, what happened to the volume?
Constant.
Will be
Yes, the
constant.
volume need to be constant. Then we can find the relationship between the pressure and the temperature. Okay, so now this is the Charles law. So Charles law is to investigate the relationship between the volume and the temperature. Okay, so first of all, you must know about the statement. What is the Charles law? Okay, so Charles law, okay, this is the statement that you have to memorize and understand. Okay, so you must write like this. For the fixed mass of gas, I believe that you all have read it before we start the class, is it? Okay, maybe
Yes.
yeah. Fatima, can you share what is Charles law from what you read? For the fixed mass of gas, uh, the
The
Charles law is about the volume and the temperature. Uh,
when uh when the volume oh the volume and the temperature is directly proportional. The volume is directly proportional to the
yeah,
temperature.
thank you very much. So the volume of the gas is directly proportional to the absolute temperature. So I will describe to you what is absolute temperature. Okay, as long this is the word that you have to read. You have to remember. As long as what must be constant? If the V and T changes,
The pressure.
yes,
Pressure.
the pressure is constant. Okay, can you read it, everyone, to me? Ah, switch on your microphone. I want to read. I want to hear.
For the
For the
For the
fixed
fixed
mass,
fixed
the
mass,
volume
mass,
of
the
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 gas
volume
is
of
volume of
the
the
directly
gas
gas
is
is
proportional
directly
directly
to absolute
proportional
to the
to
temperature
the
absolute
absolute
temperature.
temperature. Temperature is constant.
Yeah, blah 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 blah. Okay, so you read for yourself and you try to understand what is the statement of the Charles law. Okay, so the Charles law now we want to look. We want to find the we want to investigate the relationship between the volume and the temperature of the gas. Okay, right. So the statement of the Charles law state that the volume is directly proportional to the temperature. Okay, this is the relationship, not the formula of the mathematics. So if you want to use it as a mathematics formula, means that you have to change it into equal formula. There must be got equal sign. Okay, so V equal to that in front of the T must have constant. Okay, so this one must be constant. Okay, so V over T equal to constant. Okay, so what is constant? So the constant is, we change the formula into V1 over T1 equal to V2 over T2. Okay, so this is the formula of the Charles law. Right?
So teacher,
Yeah? Do you have any question?
so the V2 over T2 is the constant.
Yes, actually it is constant. Constant can be anything. So this formula is used when you are being given two situations. Let's say the volume of the gas for the first situation is this. The T of the first situation of the gas is this. So the next question is want to know what happened to the volume when the temperature become like this, like this. So it is just like a ratio, the perkadaran. Okay, so we use this formula to solve the question about the Charles law. Okay, yes,
Teacher,
anything?
why we did not put the pressure? Because you said the pressure is
Yes.
constant. Then why we do not put pressure at the
Oh,
constant?
okay. Now, because pressure is constant. Pressure is constant means that you didn't change anything about the pressure. So let's say we have the box here. Okay. So inside the box is the particle of gas. Okay. We want to investigate the volume and the temperature. Okay, you don't miss about the pressure. What is defined by the pressure constant? Okay, it cannot use in the formula. The constant means that you have to maintain the pressure here. Okay, the pressure of the gas inside here must be constant. You just want to find the relationship between the volume and the temperature so that the pressure need to be constant. Let's say you put the constant of 10 Pascal. So, uh, for the whole experiment, make sure the pressure is constant to 10 Pascal. Okay, the rest, the volume and the temperature will changes. Okay, so for this formula, okay, the constant here means that there is something that we use as a fixed variable, as a fixed nilai. Okay, so when we want to find, as I said just now, there is two situations. So the first situation is like this. The second situation is like this. So we want to know what happened to the volume or the temperature when the situation is changes. So we use this formula. V1 equal T1, V1 over T1 or equal to V2 over T2. Okay, everyone? Hi Azwa. Hi Azwa. Hey, dia muncul sekejap je. Okay, so
Yes, teacher.
yes. Where are you just now? Missing somewhere?
My internet is not that strong.
Okay, never mind. Okay. Thank you for responding. Okay, so we want to know about the absolute temperature. Just now I said to you is about the absolute temperature, is it? Because we have two types of temperature. So temperature in unit degree Celsius and the temperature in unit Kelvin. Okay, so the absolute temperature refers to this temperature in unit Kelvin. Alright, so what is actually the absolute temperature here? Sekejap. I need to... Okay. So the absolute temperature is the lowest temperature of the gas. Okay, when its volume or the pressure is zero. Okay, so just now Charles' law dia state that the volume is directly proportional to the temperature, right? So if we plot the graph will be directly proportional. Is it? The graph will be directly proportional. Okay, right. What happened to my keypad? Yeah, okay, sorry. Okay, so this one. Okay, so this is the volume, this is the temperature. So the volume, it might be in meter cube and the temperature will be Kelvin. So from the Charles law, it states that it will become directly proportional. So what happened to the graph? Alia?
Yes, teacher.
What happened to the graph when it is directly proportional? What is the shape of the graph? Directly proportional, Alia?
Straight line.
Yes, straight line begins from zero.
Zero.
This one. Oh, sorry. Oh, what happened to my keynotes? Hold on. Okay, so directly proportional is like this. Straight line begins from zero. Okay, this is the Kelvin. Okay, we use the Kelvin temperature. So it stated that in Charles' law, the volume will be directly proportional to the absolute temperature. Okay, now if we use temperature with unit degree Celsius. Okay, what do you think? Is it start with zero?
No.
Okay. So afterwards, we will conduct the activity to prove that it is not start from zero if we use the degree Celsius temperature. Okay. So if we use the degree Celsius temperature, Okay, what you will get is here. Okay, so you will get like this. Okay, it's not begins with 0. Okay, so here, okay, the intercept at the x-axis shows that the temperature is negative 3 Celsius. Okay, so what is the volume at this point? Anis, what is the volume at this point? Look at the graph here. It is volume against temperature. So when we plot the graph, we will have the interception at the x-axis. That is negative 273 degrees Celsius. Okay, so what is the coordinate here?
Negative 2.7320.
Yeah. 273 degrees Celsius. Negative 273.
Negative 273 Celsius to 0.
0. So what is 0? So point here
The
is
volume.
Yeah. So dia negative 73 and 0. So the volume is 0. Okay. So the absolute temperature state that the lowest temperature of the gas can be cooled down until the volume or the pressure of the gas is 0. Okay, so that means negative 273 degrees Celsius is the lowest temperature of the gas can go. There is no lowest temperature than that. Okay, so during this time, when the gas is being cooled down until the maximum temperature is negative 273 degrees Celsius, okay, the volume is already 0. So it seems that there is no space between the gas anymore. All right, so this is the lowest temperature that gas can go. So the absolute temperature is the lowest temperature of the gas, which its volume is 0. That is absolute temperature. Okay? Clear? Alright. So this negative 273 degrees Celsius, okay, also known as 0 Kelvin. Okay, so this 0 Kelvin known as absolute temperature or absolute 0. Okay, did you get it? Okay, that is the relationship between the degree Celsius and the Kelvin. Why we need to plus the 273 where we want to change the degree Celsius into Kelvin. Okay, everyone clear about that? Okay, so okay, let's for example, okay, so now we know that 0 Kelvin equal to 273 degrees Celsius. Okay, so if I have 10 degrees Celsius, how to convert into Kelvin?
Plus
Yes,
273.
because 0 degrees Celsius equal to 273 Kelvin. Betul tak? So 10 degrees Celsius equal to 273 plus 10. So it will be 283. Yeah? 283 Kelvin.
Kelvin.
Okay. Understand? Okay. So this is the example. This is the example 8 and example 9. Alright. So I will give you the classic link so that we can discuss there. So you can write it on your slide and I can comment about your answer. Okay, hold on. So let's check the class cake. Okay, I copied the link. Okay, I put it in the, oh sorry, in chatting. Okay, everyone, let's go to the class cake. Okay, so this is the example. This is the example 8 and example 9. Alright, so I will give you the class cake. Okay, copy the link so that we can discuss there. So you can write it on your slide and I can comment about your answer. Okay, hold on. So let's check the class cake. Okay, I copied the link. Okay, I put it in the, oh sorry, Yeah, Amni already here. Huda Nabila already here. Nasrin. Okay, everyone here. Yes. Yeah, anything? Someone raise hands. Who raised hands just now? Okay. So please check at which page? Yeah. Okay. At page 3. Is it page 3? Yeah, I am right now in Alicia Christina's slide. Okay, let's do the example 8. Afza, can you read the example 8? The question?
A sample of gas has a volume 100 cm cube at 20 degrees Celsius. To what temperature would you have to heat if you wanted to double the volume to 200 cm
Yes. So
cube?
now, Alicia, this is your slide, is it? Okay, what is the formula that we want to write?
V1 over T1 equals to V2
Yes,
over
please
T2.
write it. So everyone, please write it. What is that, Alicia? Okay, so example 8, sample of gas has volume. So volume and the temperature. So we know that this is the Charles law because there is the volume, there is the temperature. Okay, so we use the formula V1 over T1 equal to V2 over T2. Alicia. Okay, so the question asks to find the temperature when the volume is double to 200 centimeter cube. So you have to write here, Alicia. Yeah, I changed my color of pen.
Yes, teacher.
Yeah, V1 equal to 100 centimeter cube. Okay, T1 equal to 20 degrees Celsius. Okay, so please remember that in gas law, all the temperature must be conducted in Kelvin. Okay, when you want to use the formula, you need to convert the degree Celsius into Kelvin. Zulaika, do you understand about that? So please convert it. Where is Zulaika?
Yes.
So 20 degrees Celsius convert to Kelvin plus 273. Okay, Alisha. Ya, berapa? 293. Yes, thank you very much. 293 Kelvin. That is the T1. Okay, kemudian double the volume to 200 centimeter cube. So this is the V2. Understand tak, Alisha?
Understand, teacher?
So V2 is 200 centimeter cube. Now they want to find what is the T2. Okay, so everyone use the formula. So I want to see the rest of you. Who else here? Okay, Alicia, Afza, Ain Najiha. Yes, Alicia Najwa, Amni Najiha. Okay, so everyone is writing now. Please write, please write. Yeah, Iman, where's your answer? V1 T1 over V2 T2. Iman Nadira? Okay, Inshira. Okay. Oh my God. Hold on. Okay. Alright, good. Okay. Inshira still calculate. Okay, do you have a calculator with you right now? I've told you already to prepare with the calculator, with the pencil, with the pen, the paper, because you want to do the lesson. So you have to prepare with that. Okay, so who else here? Julia, where is Julia? Julia, yoo-hoo! Where is Julia? She's not here.
Yes, teacher.
Yeah, what happened? Why you didn't join the class cake?
I am joining. My internet is a bit low.
Oh, Okay, never mind. Okay, do you have any paper with you right now? You can calculate it manually. All right, Julia, did you hear that? Julia, something wrong with the internet.
Yes, teacher.
Yeah, do it manually. Okay, Nasrin seems like finish it. Nia Kalila also. Nisa, very good, Nisa. She got the answer already. Okay, Shafika still calculating. Nuha Afika also calculate. Yes, Filza. Where is Filza? No, Filza. Where is she? Where is Filza? Yoo-hoo! Filza, are you there? Yeah, what happened? You didn't join the class key. Just now you just enter. Okay. Do it. Putri Aisha. Okay, Putri Aisha done already. Rafiza. Where is Rafiza
has a
Shakira?
problem internet connection.
Okay. So how I want to contact with her? I want her to do the...
I already messaged her to do it manually.
Okay. All right. So she cannot attend the class at all? Faziana?
I think yes.
I will message Rafiza. Where is she? Okay, the rest continue. Rafiza. Okay. So I think we have a problem here when we on the camera, is it? Because it will increase our data. Is it? So if you think that your data will getting trouble when you open the camera, it's okay. You can off your camera so that you can reserve your data for the whole of the class. Okay. All right. So she's text me already. Okay, I understand the problem. Okay, so Raihana Husna. Okay, let's check the Raihana Husna answers. Yeah. Okay, so the answer 42 is 586 Kelvin. So is it correct, everyone? I think it is correct.
Yes, it is.
Yes.
Right. All right. So I want to see the answer of Putri Aisha. Yes, good. Okay, who else here? Iman Nadira. Okay, good. Yes. All right. Good. Iman Nadira here. Fatima Zara. Okay, yes, very good. So you understand, eh? Okay, good. Okay, the rest of you, I will check it later. Okay, for Anis, I want to check the Anis first. Anis, where is Anis?
Yes, teacher.
What happened?
I cannot
Where's your answer?
write because my iPad hang.
Okay, so you have to restart it and enter back into the class.
Okay, teacher.
Okay. Yeah, when we're dealing with the technology. Okay. All right. Okay, very good. Now we move to example for the next page. Page 4. Example 9. Okay, everyone? Okay, look at the question. I would like to call Yasmin Suraya. Are you here, Yasmin Suraya?
Yes, madam.
Okay, please read the question.
The diagram shows a glass tube containing some trapped air inside it. At 17 Celsius, the vertical column of trapped air is 29 centimeters. What is the vertical column of trapped air at the temperature of 57 Celsius?
Okay, so this question is a bit different. Okay, so can't you see that what is the V1? The temperature, the T1 is what? Who is page? Is it Alisha?
17 Celsius.
Yeah, okay. Alisha Najwa. Okay, I'm sharing your screen right now. Okay, please write T1. 17, is it?
Yes.
Okay, write it. So 17, you must conduct in Kelvin. Okay, convert it into Kelvin. Very good. So you get 287 Kelvin. Okay, what about the V1?
Teacher, I think P1 is 290.
V1 is
Because
290.
yeah, I got it.
T1 or V1? Faziana.
Yes, teacher.
P1.
Teacher. It's 290.
Oh, T1. There is something wrong with the calculation, is it?
Yes.
17 plus 273. Yeah, 290. Alisha? 290. Okay, credit. Okay, very good. Okay, now V1. Okay, how to find the volume? Okay, this is the trap egg inside the vertical column here. Okay, Alisha, I need to make some writing on your slide here. So this one, 29. Okay, so actually, why we want to calculate the volume must be conducted in meter cube. There is cube here. Okay, so this is the height. Is it the vertical column? 29 centimeter. It is the height. Is it? So height is meter. Sorry, centimeter. Centimeter cube. So centimeter. So how to kita nak jadikan dia sebagai volume? So you have to multiply with area. Is it? Yoo-hoo! I'm talking to you guys.
Yes, teacher.
So that you have to multiply it with square here. Then you get centimeter cube. Okay? So, the problem here, we did not know about the area. Okay, so how to write the V1? Any idea? Let's say the area is A. So what we want to write the V1? Because the V1 is the volume. The instruction, the information given is in centimeter. It's length. So what must you write for V1?
29
centimeter
Yes,
cube.
very good. Thank you. Write it down, Alisha. 29 A. A is represent the area. Okay, right. Now, the situation, what is the vertical column of the trap air at temperature of 57 degrees Celsius? Okay, T2. T2. Okay, calculate. Girls, please calculate. T2 is 57. So what is in Kelvin? What is in Kelvin? Okay, write it down, Alisha. Filza, are you okay, Filza? Filza? Yeah, everything okay? Okay, Amni Iman, everything okay? Sophia Khadija, is it okay? Okay, very
teacher.
good. Wan Huda Nabila? Okay,
Yes,
everything
teacher.
okay?
Yes,
Okay.
okay, teacher.
Alright, so for V2, okay, how to write that? V2, Alisha, V2. Okay, so V2, we want to find the V2. Okay, so V2 means that V2 times A. Okay, write it, V2A. V2A. Alisha, V2A. No, V2 equal to V2A. Alright, okay, so substitute it into the formula, please, everyone. So the A for the V1 and the A for the V2 you can cancel. Understand? Yoo-hoo! Do you understand?
Understand, teacher.
Yes, okay. So I want to look around to the rest of you. So Alisha, continue with your work. Yes, who is here? Okay, very good. Zulaika. Okay, Zulaika is still calculating. Yasmin, yes. Okay, I want to look at Yasmin.
Teacher, I just want to make sure we can cancel the A.
Yes, cancel the A because it is in the same capillary tube. So the area will be the same. Understand, Faziana?
Yes, I understand.
Okay, yeah. Okay, Yasmin. I am in your slide right now, Yasmin.
Yes, madam.
How is it? Okay, let me see. Okay, you're still calculating? Okay, show me your calculation. Okay, yes. So who else here? Azwa. I want to see Azwa too. Yes, Azwa is still calculating. All right. And this one good. Okay. So you want to find the V2, Azwa? Nuha Afika. Nuha Afika, where are you? Okay, she's calculating. Good. Zaida Amira. Yeah. Most of you are still calculating. Who's ready with the answer? I want to check. Tavi?
Me, teacher.
Okay, Fazliana.
Teacher.
Okay, Fazliana. Can you raise your hands in Kaskik so that I can find you? Okay. What happened, Fatima, Zara and Nasrin? You have any problem? Okay, Fazliana, I'm here.
No, teacher.
Okay, so Fazliana, B2, why there is still A in B2?
Oh, I thought the final answer we have to times it with A2.
Oh, no need because we want to find the V2. So A is already cancelled. You have to put the A. You have to show the A to be cancelled. Okay, Faziana?
Okay.
Okay, okay, who else here? Anyone want me to help? You can just raise hands. Are you Nazira? Are you there? Are you Nazira? Okay, are you Nazira still calculating? Good.
Yes, madam.
Okay. Are you okay?
Yes, madam.
Okay. Anis?
Yes, madam.
How is it? Alright. So
Okay,
what is your
madam.
answer for V2?
33, madam.
Yes. What 33? The unit of the volume. Everyone, don't forget to put the unit. Put it in unit. The unit. Centimeter. Okay, centimeter. Okay, so V2 actually is volume, but when we cancel the area because we can use the height as represent the volume. Okay, so no need to put the cube. Okay, very good. Yes. So if you have a problem, you can raise hands so that I can check. Okay, here Alia Hidayah. Okay, Alia Hidayah, what's your problem?
No problem, teacher. I want you to check.
Okay, alright.
Teacher, I want to
Uh-huh.
ask, how should we cross the A? Just tulis V2 A is equal to 29A and just cross it, teacher.
Yes, because area is area we use the same tube. We use the same tube. So the same tube means the area is same. So we just we can cancel off V1, V2, A and A. So cancel off. Okay?
Okay.
Okay, Alia, what is this? Alia? V2
Yes.
equal to V2 what? Is it A? Is it A?
Yes.
A,
Yes.
capital A, darling. Capital A. Okay. Alright. So I hope everyone understand how to solve the problem involve the Charles law, yeah? Okay. Is there any more questions? Raihana Husna. Raihana Husna. Where is Raihana Husna?
Yes, madam.
Okay. How are you? Okay? Okay, I want to check your side. Okay, very good. Okay, you done it. Good. Good. Okay. Very good. Good job, everyone. Okay. Yeah. So we leave this class cake. Later on, we will come back to do the experiment. Okay, what's next? What's next? We want to carry the virtual experiment about the Charles law. Okay, just now I've told you that we supposed to get the graph of the Charles law. Where is it? Okay, like this. Okay, so after this, we will conduct the virtual experiment. This is the first time we will conduct the virtual experiment to prove that what Charles law state. Okay, so he state that the volume is directly proportional to the absolute temperature. But for today's experiment, we want to use the temperature using Celsius, degree Celsius. So it might be you get the graph like this. Okay, the graph with negative 273 degrees Celsius. But of course, we cannot extrapolate until negative 273. So you will have only at the positive axis. Okay, everyone, are you ready?
Yes.
Okay, so I want to share you the experiment. Okay, did you see it, guys? Can you see them?
Yes, teacher.
Yes,
Okay.
yes.
This is the experiment to prove the Charles law. Okay, this is the this is the data that you need to fill in. So I will show the experiment to you and describe how the experiment will be conducted. You will measure the temperature on your own and the volume also on your own. Alright. So draw the table. Okay. With two column, temperature in degrees Celsius and the volume. So the volume will be in y-axis. There's some arrow there. So the volume must be in y-axis and the temperature will be in x-axis. Okay. So the temperature that you want to measure is from 20 degrees Celsius, 25 degrees Celsius, 30 degrees Celsius, 35 degrees Celsius, and 40 degrees Celsius. Did you get it, everyone?
20 until 40,
Yes,
right?
20 until 40. Okay, I show you how to conduct this experiment, okay? So Charles' law. Okay, sorry because there is something wrong with the sound. So I need to explain to you. Okay, hold on. Hold on. Okay, so this is the first thing that you must do. You have to fill in the water into the beaker. Okay, then you place the syringe with the plunger. And then you put the temperature. The thermometer into the water. Right? And after that, okay, so there is the air inside the syringe. And the syringe must be closed end because we want to trap the air inside the syringe. And we put load on the plunger, okay, to make sure that the plunger stick at the place. Because we want to constant the pressure inside. So we don't want to explode it. Okay. And then we heat it. Okay, we heat the water. And there is a bowl of ice there to reduce the temperature of the water. Okay. Don't forget to stir your water. Why we need to stir? Nisa? Nisa, why we need to stir the water? Nisa Patricia?
Yes, teacher.
Yeah, why we need to stir the water when we heat it?
so that is it because to make sure the temperature is constant?
Yeah, so the heating process will distribute to all the water. Okay, so when we place the water, when we put the ice, okay, so when we put the ice, so the water will increase so that you have to throw away the balance of the water. Okay, so this is the graph that you're supposed to get. All right, everyone, is it clear? Is it okay? Right. So, okay, let's continue with the experiment here. Okay, are you ready? So, because I cannot repeat the experiment here, so this is the apparatus. So, you can see the temperature on your left side. Okay, so you have to measure until 20 degrees Celsius, and then you measure the syringe. Okay, I show you. This one I assembled already, and I put 1 kg on the top of the plunger. So I place the water. All right. Okay, so how to measure the syringe? Okay, I will press the syringe. Okay, then you can see the scale of the syringe. Okay, everyone, can you see it? Alia, can you see it?
Yes.
Yes.
Okay, then, okay, you can see the black line there. So measure the volume of the air using the black line there. So if the line is in the middle of between the scale, okay, you take the value, the higher value. Let's say 35.5, it means 36. If it is 45.5, it is 46. Understand? Okay, everyone, are you ready? Yoo-hoo!
Yes, yes.
Okay, alright. Okay, let me on the stirrer. Okay, so to get 20 degrees Celsius, I need to put ice. Okay, so I will getting it lower. Okay, hold on. Okay, and I remove the ice. So I heat it. Okay, get ready, yeah? Okay, now. Okay, get ready. It becomes to 20 degrees Celsius right now. Okay, come on, everyone. Good luck. Okay, so 20 degrees done. Now we move to 25 degrees Celsius. Okay, so check the volume. Okay, now the temperature keep on increasing. Now we're heading to 30 degrees Celsius. Okay, get ready everyone. Yeah, now 30 degrees Celsius. Okay, next 35 degrees Celsius. Come on. Lisa, I like your smile. Okay, 35 degrees Celsius, everyone. Look carefully to the syringe. Look carefully to the volume of the syringe. It is in centimeter cube, yeah? So the temperature is in Celsius, degrees Celsius. Okay, we are heading to 35 degrees Celsius right now. Okay, come on. Yes, now 35 degrees Celsius. Write it down. Okay, PT for Rafiza Shakira. She's facing with the internet line. Okay. Now the last one. 40 degrees Celsius. 40 degrees Celsius. Yeah, final temperature. Final temperature. Yes, almost there. Yeah, 40 degrees Celsius. Done. All right. So, how is it, everyone? Did you get the data with you together right now? Yoo-hoo! Did you get it? Amni Najiha, how is it? Yeah, very good. Thank you very much.
Yes, teacher.
So,
Yes.
now please take out your graph paper. Okay, so I've sudah ada ni. Okay, so please take out your graph paper, your pencil, your meter rule 20 centimeter and plot the graph about graph of volume against temperature. Please remember temperature in degrees Celsius. Okay, so I give you how many minutes you need to plot the graph. Actually, the data you have to put it into the class cake, yeah. The data inside the class cake. Okay, and then you put your graph. Okay, let me show you. Okay, so on page 2, yes, you have to upload your graph. Okay, take picture of your graph and upload it in the class cake. Can you do it for me right now? Girls? Yoo-hoo! Can you do it for me? Okay, so do your work. I give you 5 to 10 minutes to complete it. Okay. Go on. So I like to open some songs to you all.
Teacher, I want to ask.
Yeah. Continue. Yes. Yeah, what is it, Zulaika? Zulaika, where are you? What do you want to ask? Zulaika? Yeah, what happened? I heard that you want to ask me. What is that? Okay. So
Teacher,
yeah.
how about the scale?
Okay, the scale. What's wrong with the scale, Fazliana?
Or did you teacher tak set
Scale is
and
on your
scale
own. So just now kita pakai 20, 25, 30. That one for the temperature, is it? So it must start with 0. So you can use the starting point is 0, so that you can use maybe 20, 40, or no. Maybe you pakai 5 degrees Celsius also can. 5, 10, 15, 10. Okay, the volume one same as the same. Okay, try to do on your own first. Then afterwards we will discuss about the graph that you get. Okay, everyone, are you okay? Are you Nazira? Okay. Are you Nazira? Are you okay? If anything you want to ask, please ask me. Okay.
Yes, teacher.
Something in the air right now.
Teacher. Yes. Just now the experiment for the temperature 30 and 35, I get both 40. So the graph would be, you know what I mean, curve. So should I just follow or?
The graph is not curved. Never mind. You put the point already. So the graph
Yes.
should be straight line. Never mind. We have learned before when you plot the graph, it's not necessarily have to place the line on all the point. Okay, best fit line. Don't you remember about the best fit line?
Yes, teacher.
Okay. Huda, do you is Huda here?
Yes, I'm here.
Yeah. You didn't Huda. Oh, okay. So you have another slide ke inside the class kit? For example,
Yes, but
Ah.
my internet is kind of lagging, so I already did it, but it's like not appearing.
Okay. All right.
But the example then I already finished it. I guess that's the result.
Okay. Bye. So everyone, how is
Teacher.
it? Have you finished to plot the graph? Because we have some more activity that we need to complete it for today's class. If you've done it, please share in the class kit, yeah? Okay, none of you? Alia, are you okay? Alia? Is it okay? Are you okay?
Yes. Yes, I'm okay.
So I'm waiting for the graph. Please upload it. Okay, are you having problem with the scale or so on? You can ask me. Okay, those who have uploaded or upload the graph on the class kit, please raise your hands, yeah, so that I can go to your slide. So I'm now marking your example 8 and example 9. Okay, girls, how is it? Amni Najiha, are you okay? Have you plotted the graph? Yoo-hoo! How is it?
Yes,
Is it
teacher.
okay with the graph? Anis?
Okay, teacher.
Anis? How is
Yes,
it?
teacher.
Have you finished it?
So far, so good.
Okay.
Yes, teacher. Wait, I want to upload.
Okay, thank you so much. Julia, are you there, Julia? Julia? Where is Julia? Where is Julia?
Yes, teacher.
What happened? You didn't answer in the example 8 for the class kit? Julia?
Teacher, I cannot open the class key.
Because it's still loading.
Still loading. Okay, never mind. You calculate using manually, okay? You got the papers with you, is
Okay,
it?
teacher.
Okay. So you have any trouble with the example 8 and example 9? You understand about the question? Can you answer it? Julia? Hai. Senyap dah. Okay, Nuha has done his graph, her graph. Okay. Yes, I cannot see clearly. So I need to make it bigger. Yes. Okay. Nuha, Afika. Okay. Alright, but when you upload your graph, it's not seen so clear here because you are using pencil, is it? Oh, you cannot see the screen here. Okay, let me share screen. Nuha, Afika. Okay, so this is your graph. Okay, it's not so clear because you are being uploaded it into the in here. Okay, so can you read the axis, x-axis? Is it 10? Okay,
Yes.
10, 20, 30, 40, 50, 60. Okay, good. Okay, for the y-axis?
Also 10, 20,
Okay,
30.
so you get straight line graph, but it is not begins from 0, is it? So actually, it is same with
Yes.
the graph that we discussed just now. That when we extrapolate the graph, it will intercept at negative 273 degrees Celsius. Okay, good. Very good. Thank you, Afika. Okay.
Thank you, teacher.
So who else want to share the graph? Just now, who share it?
Me, teacher.
Who is me? Who is me? Okay, can you raise hands? Okay, you raise already. I cannot see your hands here. Okay, Afrina lah. I check Afrina dulu, Nasrin. Ain. Okay, so this is good. Yeah, this one clearly. It's very clear. Okay, this is Afrina graph. So everyone, can you see the screen right now? So this is the graph of Afrina. Afrina, can you explain a bit about your graph here?
Okay, teacher. So for the x-axis, I use the scale of 2 cm to 5
Okay, 5 cm.
And same goes to the y-axis.
Right. Then, what about your graph? What is the shape of the graph?
My graph is linearly
Yes, linearly increase, yeah. So if you continue to extrapolate the graph until it intercept at x-axis, what do you get?
I will get negative 270.
Yes, you will get negative 273 degree Celsius. Okay, everyone? Is it okay? Because we need to continue with the second activity.
Yes.
Alright, so I will check the graph later because you uploaded it here already. So that I will check it later. Alright. So now is the second activity. So I will break you into break room. Okay, this is the group activities. Okay, so I divided already you into 5 groups as I told you before. And then first using the Jamboard, so your leader of your team will share the Jamboard link together with you all. So this is a 10 minutes activity only. And then after settle the question, okay, you need to answer exercise 2 and 3 only. So 2 question only to be answered. Example 8, example 9, done already. And then the second the second question, question 1 and question 2. Okay, the rest you let it be. Okay, then you open the apps of the what is that? Physics Studio. Okay, and find the properties of matter and try to answer box 1 and box 2. So I share you the ni. Hold on ah. Where is it? Oops. Physics Studio, where is it? Yeah, fine. Okay, your please leader of the group. Okay, so remind me later. Okay, open this one. States of matter. Okay, states of matter, and then you find this properties of gases. Okay, so only settle the quiz in box 1, okay, and box 2. Okay, so it's that's only your task for this group session. Okay, is it clear, everyone?
Yes, it's clear.
Okay, so
Yes, teacher.
yeah, so I will give you the link for the break room. Okay, hold on. Okay, those who are in main room, you don't have to move anywhere, yeah? You stick in this room. Okay. Alright. Okay. So this is about 15 minutes only. So hopefully you can finish it as soon as possible. Assign breakout room. Yeah, hold on. Okay. Alright, so you may go for the breaking groups. So you can close your camera because it will consume a lot of data. So you just let it close.
Goodbye, teacher.
Okay.
Okay, thank
Yeah.
you, teacher.
Okay.
Bye, teacher.
Alright. Left the group and don't forget to return back, yeah.
Okay, so teacher, can I start now for the main group?
Yes.
Okay, do I need to present the screen?
Pardon?
Can't
Do
hear
I
you.
need... sorry. Do I need to present the screen?
Yes. Every one of you. The leader of the group
Okay.
needs to present.
But
Okay, I need
you
to.
are presenting.
Okay, I'm sorry.
Yes.
Okay, sorry. Hold on.
It's okay.
Hold on.
Okay.
So I stop the presenting.
Okay. I'm going to share my screen. Okay, can everyone see my screen clearly?
Yes.
Yes.
Okay. So let's get started with the first slide. So what are the three variables in gas law that we learned just now? Everyone please state your answer.
Should we just say it or write on a sticky note?
Use the sticky note lah.
Okay.
Okay, girls, you need to be quick, yeah? So because we don't have much time.
Okay. Okay, so I can see 3 answers right now. Where is okay. Okay, I can see more answers coming in. Okay, so can I ask Alisha to say what are the 3 variables of gas law?
Okay, the 3 variables are pressure, temperature, and volume.
Alright, so everyone got it correctly. Okay, so let's move to the next slide. Okay, so pressure of gas, the relationship. What is the relationship? Or explain the pressure of gas. Okay, so Alisha answered, the faster the collision between particles that hit the wall of the container, the greater the pressure. Yes, that is correct. Okay, Yahid, Ali Hidayah also correct, but you need to switch the position. Yeah, like that. Yes, yes, that's correct. Okay, yeah, so everyone got it right. Nice work, everyone. Okay. Alright, so let's move on to the next question. On slide 3, temperature of gas. Just now we just discussed on the pressure, so now we are going to discuss on the temperature of gas.
Okay, girls, you need to actively discuss in this group, yeah? I don't want to hear the silent voice because this is a group discussion. Okay? So you
Okay,
can
teacher.
ask, okay, maybe because this one we have learned it already for the previous topic just now, we discussed it. Maybe during the questions, when you answer the questions, maybe there will be more actively answered among you. Okay,
Okay.
I need to melawat the other group. So please be good. Okay.
Okay,
Alright,
teacher.
teacher.
Okay,
Okay,
teacher.
teacher.
Okay. So everyone got it right, but you need to switch the position. You need to state the higher the kinetic energy first, and then baru the higher the temperature. So everyone got it?
Yes.
Okay.
Okay. Everyone is doing great. So volume of gas.
What about the volume of gas?
Okay, so Alisha answered the further the distance, the larger the volume. The distance. Okay, yes, correct. But Anis, you have to state the further the distance between particles. Okay.
Okay.
Alright. So I think everyone got it right. Thank you so much for the answers. So next you don't for the next slide you don't have to write down the sticky notes. I will be picking either one of you to answer the question. So I will pick Afza. Can you state the Charles law?
State to Charles law is mean the definition.
Yes.
Uh,
Okay. So what does the Charles law state? Afza, you can just say it in the mid.
okay. Charles law states that for a fixed mass at constant pressure, the volume of the gas is directly proportional to its absolute temperature as long as the temperature is constant, and the formula is V1 over T1 equals to V2 over T2.
Alright, that is correct. But for the statement that you stated just now, it is as long as the pressure is constant, not when the temperature is constant. Okay. Alright. So next, I would like to ask Ani Zafira to wait. Try and answer the okay. Example A, we already did it just now. Try to answer question 31. Maybe you can scribble on the board and then you present it to the screen. Can you, Ani Zafira?
Wait, I don't find the question. Okay, okay. Wait.
Okay. Okay, I can see Anis is in the slide. Okay. So the others can also do it by your own and then we can check it together. Okay, so Anis, are you ready?
Wait. Can someone help me? I lost bit.
You cannot find the slide?
No, I already found the slide.
Can you find the slide?
But
Okay.
I forgot how to do.
You need to press on the pencil button on the bottom right side. Can you? Can or not?
Anis, what happened to you?
Wait, teacher, I forgot the part.
It's like a million years you didn't open the Jamboard. We just use the Jamboard always in the class, right?
Yes. Wait.
Use the pencil, don't use the sticky note. You can just write on the board directly. Anis, are you okay?
What about the rest of you? Are you have trouble for this question?
We're trying to calculate, teacher.
Okay, this question also use the vertical column, right? Just like We discussed it just now. For it is actually V is for the volume, so that we can use that 10 centimeter multiply with the A, but then the A will be cancelled at last, right?
Okay. Anin, it's okay lah. I will ask orang lain.
Yeah.
Wait. I want to choose.
I want to try.
Okay, Alia Hidayah. You can present it on the screen. Just write down your cadangan kerja. Oh, okay. Alia, can you explain while you are writing?
Wait, I cannot write my jalan kerja. So firstly, we need to change the 7 to Kelvin, right?
Yes, that's right.
Okay, you just finish this question and then go to the physics studio afterwards, okay?
Alright, teacher.
Okay, teacher.
T1 27 plus 273, okay.
Okay. The V1 is okay. The V1 is 10A, right? Because 10 is the height. For the volume, we need 2 times the area. Do you get it? Capital A. Don't use small a. Okay. Alright. And then the next one, T2 is the one that we need to find. And then it is given that the vertical column of trapped air is 10.9 cm. So for the V2, it is 10.9 A. Alright. Okay. Then can you do the next working steps? Okay.
Okay, what about everyone else? Are you okay? Can you answer the questions?
Yes, teacher.
Yes,
Yes, teacher.
Mm-hmm.
Okay.
Okay, what is the final answer there? Okay, your friends in the other groups are finished the Jamboard. They are using the Physics Studio right now to complete the quiz there. So you need to be quick. Okay? Mm-hmm. The rest of you, are you calculating?
Yes, teacher.
Yes, teacher.
Mm-hmm.
Okay, Alia, you are close to the answer. What do you get? Or maybe Alisha can state the answer.
I got 327 Kelvin, and then I minus with 273 because the answers is in degrees Celsius. So I got C, 54.
Yes, correct. So everyone got the answer?
Yeah.
Okay.
Yes.
So now let's move on to Physics Studio. Okay.
Okay, jump to the questions. Quiz,
Okay, teacher.
Okay, all of you can open the Physics Studios. So Afrina also share the screen. Okay, the rest you can answer on your own, but you discuss to find the answer because you need to find the correct answer for the 5 questions in the quiz.
Teacher, the question is the section of properties of gases for box 1
Yeah.
and box 2, right?
Yes, yes. Click the first box. Properties of
Of
gases, yes.
property. Okay.
Properties of gases, yes. Okay, I'm ready. Okay, I'm ready.
Okay.
Click it. All right. So find the spot quiz up there. There is a spot quiz up there.
Okay.
Mm. All right. So
So
everyone,
this is the
are you
question.
okay? Okay, discuss it.
Okay. So Alisha, can you read the question?
My question is different from what you
Yes, me
present.
too.
It's in
Oh.
different.
Me same.
Everyone got different.
I got same.
Maybe it is randomly. I think it is randomly lah. It's okay lah. We do it together. What I presented. Okay. So Aisha,
So
can
I
you
read
read
it.
what I present? Yeah.
The diagram show 4 open dishes. Each dish contains water at the same temperature. The dishes are different shapes and a draught blows over 2 of them. From which container does the water evaporate at the greatest rate?
Okay. So, who remembers the factors that affect the rate of evaporation that we learned in lower form? Anyone?
The area, right?
Yes, the surface area. The larger ke the smaller the surface area, lagi tinggi rate of evaporation.
The larger.
The larger.
The larger.
Okay, betul. Okay, sekarang if we look at the questions, there are 2 answers that is suitable with the large surface area. So which one is the most accurate one?
The left.
Right one or the
But
left?
the first one, what
Okay,
with
fine.
what
Ada
with the
hidayah.
arrow? The
The
first one.
first. What?
The arrow shows the air, movement of air. But dekat ada. Yeah.
Is it the first and the third one?
I think the first.
Okay. So let's try and answer. The first one. Okay. Oh, okay. I don't know if if there is a right,
Yes,
then the answer is correct.
it's correct.
Okay,
Yes,
teacher.
it will show the green tick. Okay, next question.
Okay, so question number 2, can I ask Amni Naziha
Yes.
to read the questions? Yeah.
Gas molecules striking a container wall cause a pressure to be exerted on the wall. Which statement explain this?
Okay. So let's check the answers one by one. When a molecule rebounds mean bila dia dah berlanggaran lah, collision. There must be a change in its momentum, temperature, speed or energy.
Temperature, right?
Energy.
I think it's either speed or momentum.
I think speed.
Momentum?
Because
Okay. So okay. It's okay. Cuba tengok. Okay, gas molecule striking a container will cause pressure to be exerted. So when a molecule rebound, there must be a change in its. So what do you want to answer?
I think energy. Kinetic energy. Energy.
Girls. Okay.
Okay.
So when the particle hits the wall, okay, the particles already has the mass and also has the velocity. So when it hits the wall with a certain time, what's the sound is that?
Anizafira, please mute your
Get off
mic.
your microphone.
Okay.
I'm sorry.
Okay, actually it's change in momentum. So mv minus m1 v1 and mv v2 mv2. So actually it is about the momentum, the change in momentum.
Okay. Okay. Thank you, teacher.
Okay,
Next
next. Come
question.
on. We have 5 minutes more.
A student
It's only
blows
5
air
questions.
through a liquid using a straw. This causes the liquid to evaporate quickly and therefore to cool. Which statement explains why the remaining liquid cools? Can I ask Afza?
Kinetic energy.
Wait.
The molecules. Sabar. Therefore to cool.
It's okay, it's okay. Slow moving molecule.
The air molecules conduct heat from the liquid.
Can I try?
Okay, Alisha, what is your opinion?
I think it's the molecules with most energy leave the
I
liquid.
agree with Alisha.
Can you explain?
Because based on
Alisha?
the relationship. Yeah, can you hear me?
Mm-hmm. Yeah, can.
Okay. Based on the relationship, the kinetic energy will increase if the temperature increase. So if the temperature decrease, the kinetic energy also decrease.
Okay, so let's check the answer. The molecules with most energy leave the liquid, right?
Yes, the second one.
Okay. Yeah, you get it correct. Okay. So next question. Gases occupy volume of the, this is an easy one, container, right?
Yes.
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 Last question. The diagram represents molecules of a gas inside a closed container of constant volume. What happens to the molecule of the gas when the container is heated? So the temperature increase. What happened to the
They move
I
faster.
think they move faster.
They move faster.
Yes. That is correct. So we get all 5 questions correct. Okay.
Yes, excellent. Congratulations. You got 5 stars there. Okay, I think it's okay. It's enough for you. Okay, you can continue with the answering the quiz at your home on your own because you download it the application, is it? In your iPad, is it?
Yes.
Yes.
Okay. So I hope by this activity you can be more understand about the gas law, about the Charles law. Is it?
Yes, teacher.
Is it?
Yes,
It really
teacher.
helped the process.
Yeah. Okay. All right. So you just wait in this group, in this main group. So I will ask the rest of you to return back to the group for the closure. Okay.
Okay, thank you, teacher.
Okay.
All right. So you don't go anywhere. You stay there.
Okay,
Yes, teacher.
teacher.
Okay, Assalamualaikum dan selamat tengah hari semua.
Waalaikumsalam Puan.
Waalaikumsalam,
Okay.
Puan.
Nama cikgu ialah Yohana binti Yaakob ya, daripada Jemaah Nazir Negeri Selangor. Bersama kita lah Encik Nur Azhar, Encik Nur Azhar bin Muhammad Zain daripada Jemaah Nazir Negeri Johor. Ya, kami di sini untuk menilai cikgu Cikgu Johaida dah keluar, Cikgu Johaida? Dah tak ada Atau dia? Okey, jadi kami hari ini ditugaskan untuk menilai ya. Cikgu kamu, guru cemerlang ya? Guru cemerlang di 48, jadi dia nak Dia nak cikgu nak memohon untuk ke grade yang lebih tinggi. Jadi pada hari ini cikgu nak minta lah kalau nak interview seseorang, kita tak ada masa Jadi cikgu akan kongsikan Google Form lah untuk semua pelajar isi. Ada 3 soalan saja di situ dan cikgu akan tunggu. Bila kamu dah habis, kamu keluarlah daripada Google Meet ini. Okey, jadi belum apa cikgu ucapkan ribuan terima kasih dan selamat maju jaya. Okey? Cikgu share sekejap ya. Okey, itu adalah nampak ya. Okey, itu adalah Google Form dia. Kamu boleh klik, lepas tu turun jawab soalan, jawab dengan jujur. Ya. Sebabkan kami nak maklum balas tentang pengajaran guru kamu Okey, teruskan ya. Terima kasih.
Okay, girls. So let's make a conclusion about today's lesson. Alright, so what is the formula of the Charles law?
Cikgu Johaida.
Ya, saya Puan. Minta maaf.
Kami tengah buat maklum balas sekarang, lebih kurang 5 minit.
Alright, boleh. Okay, sorry.
Saya akan tunggu mereka sehingga mereka habis baru ya.
Boleh.
Baru kita keluar daripada
Okay, it's okay.
Cikgu belum buat conclusion lagi.
Ya, saya tadi diorang buat aktiviti, so saya just want to make a conclusion a little bit.
Okey, tak apalah, bagi dia masa untuk jawab maklum balas sekejap.
Boleh. Alright.
Senang je.
Boleh. Okay, continue answer the tu
Cikgu bagi masa 2 minit lagi boleh Sebab so far cikgu dah dapat 25 respons. Murid di kelas ni ada berapa
32.
32, betul?
32.
Okey. Lagi 2 orang sahaja. Ataupun seorang lagi ke sebab kalau campur cikgu guru dengan Nazir 3 orang kan. So, okay, one more. Okey, kalau rasanya tak ada lagi sebab cikgu dah dapat 31 respon, saya rasa dah cukup lah. Okey, terima kasih banyak-banyak. Nanti Cikgu Johanna kita jumpa lagi lepas ni dalam link yang lain.
Thank you,
Terima kasih semua. Good luck.
Terima kasih Puan.
Terima kasih Puan.
Terima kasih
Terima
Puan.
kasih Puan.
Okay, so alright, so thank you for the cooperation. So as a conclusion, tadi what is the formula of the Charles law? Alicia?
Yes, teacher.
What is the formula of the Charles law just now? We discussed it already.
V1 over T1 equals to V2 over T2.
Yeah, the T must be conducted in?
Kelvin.
Yes, it must be conducted in Kelvin. Okay, so as a homework, okay, you can check I just gave you, I think I gave you already the link, is it? About the Padlet. Okay, I just want to show share the screen lah about the Padlet tu. Hold on ni ke? Masuk tak? Tak ada
Ada teacher.
Ada teacher.
Ada. Okay. Alright, so this is the homework that you need to finish it. Okay, complete it as usual. Okay, so for the DIY experiment, you all boleh nampak ke ni?
Yes, nampak teacher.
Boleh nampak teacher.
Boleh.
Okay. Alright. So this is some of the thank you very much for those who are hand in the videos. Okay, so it's good to see your cooperation. Okay, I would like to show one of the videos. Is it by Alia? Alright, thank you very much. Okay. Okay, actually it's not relate at all to the pressure. It is more about the volume and the temperature. So when we lower the temperature, so that so do with the volume, so that the volume will be shrunk. Okay, so you don't have to you don't have to relate it with the pressure because the pressure actually is constant. Alright, everyone. Okay, so in the Padlet also we have ada tak? I letak kat situ. Oh, tak ada dekat sini, dekat Jamboard yang real situation that involve Charles Law. Situation
kat
that
Jamboard.
involve Charles Law. Dekat Jamboard. Sempat tak jawab?
Tak.
Tak sempat. Okay, so sebenarnya kalau untuk situation in our real life, okay, contoh kalau you bake cake, masak cake kan? Kenapa cake tu can be expand? Can you imagine why?
Sebab temperature yang teacher.
When the temperature increase, the gas like the cake will expand because of the volume expand, so that the cake will expand. Okay. What else? Balloon.
Teacher nak tanya. Kalau macam bola pimpong kemek tu kita masuk dalam hot water.
Yes, that one is also Charles Law. So many more application in our daily life. Okay, you can search in Google. Mr. Google lah apa lagi kan. So that nanti saya tambahkan satu lagi kolom dekat Padlet tu untuk real life situation yang berkaitan dengan Charles Law. Okay, thank you so much for your cooperation. So I have another session with the Nazir. So hopefully I can doing well. Okay, so thanks everyone. Thank you very much. Okay, so wish me luck, yeah. Right. We end our class. We end our class with the tasbih kifarah and so on. Okay, bye.
Good luck.
Bye.
Good luck.
Good luck,
Good luck, teacher.
Thank
Good
you.
luck,
Thank you,
teacher.
teacher.
Thank you, teacher.
Thank you. Bye.
Dua belas setengah. Dia jumpa balik dia.